Hi, everybody. Well, let's see. Good morning. Good afternoon. What time is it there? Is it just noon, basically? I mean, I'm not sure, but
It's in the morning, 11.
11 o'clock in the morning. Very good. Well, good morning to you all. Let me see. Share my screen. All right. Good stuff. Good stuff, everybody. I appreciate you being here. I appreciate all of you being here. I know that there's a lot of things you could be doing right now, but you chose to hang out with us online. That's wonderful. My name is Josh Long. I'm so happy to be with you, even though it's virtual. I wish we could be together. I wish we could hang out and drink rakia and, eat wonderful food and so on, but this is okay. I'm glad we can do this. I was told to turn off the camera. That's right. I got to turn that off before we get going. Okay. So let's get started. My name is Josh Long. I work on the Spring team. I'm a Spring developer advocate. I'm a Kotlin Google developer expert and a Java champion. And I spend all my time trying to help people build better software with Java and the ambient technologies around it. And today we're going to talk about a lot of these different things. And we're going to cover a lot of stuff. And that stuff is going to be covered in this Git repository. So keep note of this Git repository. It has the code. It has everything that you're going to need to follow along at your own discretion. We have maybe 90 minutes, a little bit less, so we have a lot to cover and very little time in which to do it. So I encourage you to take a screenshot of this one slide. And of course, you'll find my coordinates. So if you have questions, when you have questions, please reach out to me. I'm on Twitter and I'm on email. I'm happy to engage. I'm happy to talk. And I want to thank you for your time, obviously. A little bit about me. I work on the Spring team. As part of what I used to do, of course, it's a different world now, isn't it? But as part of what I used to do, I traveled a fair bit, and I used to go to Bulgaria, and it was wonderful. I had so many visits with Java 2 Days over many years, and I miss it, So these are on Safari on different topics. I have a book that I wrote in 2017 called Cloud Native Java, which is all about how to build applications using Spring Boot and Spring Cloud and Cloud Foundry. I have a podcast that I do every Friday. This is a podcast where I talk to interesting people in the Java ecosystem. So recently we had Dion Almayer, we had Dr. Heinz Kabutz, we have just lots of different amazing people in the Java and Spring ecosystems. I have a blog I do every Tuesday called This Week in Spring, which is a recap of all the news that fits a reprint in the Spring ecosystem. And of course, I have a screencast series that I do every Wednesday called Spring Tips, which is just me looking at corners of the ecosystem together. Excuse me, I've got a bit of a cold. Some things should not be open source. My cold is one of those things. So that's good. And of course, I have a new book called Reactive Spring, and this book is the stuff that we're going to talk about, really, if you think about it. So maybe you don't need to buy the book. Maybe we'll just talk about it right now, and you won't need to buy this book. The whole thing that we're going to talk about is reactive programming. But before we can do that, before we can have a discussion about reactive programming, we need to consider why we care about reactive programming, what motivates its use. And reactive programming is not a new thing, obviously. So let's talk about the big picture before we dive into the details. What motivates this need, right? Why are people caring about reactive programming now and instead of like 40 years ago, for example, right? And I think it's not hard to think of problems that have sort of only become very, very serious in the last, let's say, 10 years, right? 15 years at most. And so what motivates the use of reactive programming? Well, I think if you look around, it's not hard to identify problems related to our ability as human beings to go faster. How can we deliver software faster into production? And this is something that causes a lot of trouble for a lot of different organizations. They know that they need to go faster. They look at their process and they understand that there are different pools of activity in the organization. And when it comes to the developers, we try to go fast. We try and do sustainable, repeated delivery, but it's not always easy, is it? And so we look for ways to go quick, right? What can we do to go quickly, to more safely and quickly move software into production? Obviously, lots of different things that we could do. Where did I? A lot of, okay, never mind. A lot of things that we could do to go faster, but a lot of organizations, they look at their code bases and they realize that these code bases are large. They're large, big code bases with lots of people working on them. And this causes a problem because all that coordination that's required to deliver that software into production slows people down. And so they look for ways to shrink the size of the code base. They break it apart. They decompose the monolithic application into small pieces. And the smaller the piece, the fewer the people that are required to maintain it, to evolve it, to sustain it, to develop it, etc. And this allows for some very interesting things. It allows for small teams that are focused on one thing. So they don't have to do work for other parts of the organization. They're all focused on one feature, as opposed to, this is different from having people that are in different groups. You have IT, you have, ops, you have developers. Instead of doing that, you say, these people are working on the order service, and these people are working on the fulfillment service, etc. So now you have people that are grouped by their feature instead of by their role. These people are not doing work for any other team, so they don't have any wait time. There's no lead time or delay between action. This allows them to go faster and allows them to move independent of the other parts of the organization. Autonomy is very important here. Autonomy is how quickly can I move independent of the rest of the organization. So now we've got small code bases. We've got people that are focused on delivering software quickly, and we need to find a way to break apart our monolith, right? Well, of course, we can look for the bounded context. The bounded context is a part of the amazing book by Eric Evans called Domain-Driven Design. It describes a part of the domain model that stands by itself without any other dependencies. So this is a very, very useful pattern when you are looking for ways to describe these small, singly focused services. So now we have lots of small, singly focused services. These services are bounded contexts, and they have to be deployable. You have to be able to deploy them without the other services, right? They don't need or depend on other services. This is very important because now I can work on my team, and my team can deploy software without waiting for other teams. Well, once we've done this, now we have separated the modules, we've separated the bounded contexts, and they're no longer in the same code base or in the same deployable artifact. They're now communicating over the network. And here's where we get into trouble, because as soon as you build a distributed system, you have complexity that you have to deal with. That complexity is where we are going to find some pain, right? That complexity is, it's not trivial, but thankfully, there are good tools and good frameworks that you can use to address that complexity. And if you understand that you are going to have more complexity when you build microservices, if you understand that you're going to have more complexity when you build distributed systems, then you can get the benefits out of it. You can say, okay, look, I know that there's more complexity, but this move will allow me to move software into production faster and to learn from the feedback cycle of that deployment. I can see the change in production, and I can benefit from that, and I can respond to change in production. That's a wonderful thing, even if there is some complexity. So the question is, what can we do to minimize that complexity? Well, consider when we build services, there are patterns that start to become obvious, patterns that become important as you start to create more services. So today we'll talk about some of those. These are cloud native patterns. And then there's also what we can do at a service level and at the API level to make our life easier. Consider that there are 3 big pain points that we only start to see really at scale. The first pain point is how resource efficient are our services? Are the services that we're building wasting precious resources on the computer? That's the first problem. And one of those problems, of course, that it becomes very clear is the JVM's ability to create more threads, right? And even if you have lots of threads, right? So in hopefully a year, in a year, hopefully, we'll have Project Loom. Project Loom will give us green threads, right? Lightweight green threads. This is wonderful, right? Project Loom is going to make it so that we can create a lot more threads. But even there, if you try and do input and output, you're using buffered input streams and output streams. Each one of these keeps a byte buffer in memory. So now you've got, you know, 1 million threads. You've got now 1 million extra input streams and output streams, each of which has a buffer that adds up, right? Several kilobytes per input stream, output stream combination. And so you have to be more resource efficient, even in this new world. That's the first thing. The second thing is I want code that makes it easier to compose, right? Because when I move to a distributed systems world, I've got data coming from databases, from message queues, from web services, all these different things, all these different places, and they all look and feel very different. But I want some sort of programming model that lets me talk about all the different kinds of data, right? I've got data that is immediate. I have data that will take a long time. I have data that is small. I have data that is large or maybe even infinite, right? All these different kinds of data streams. They're all important to me, but right now I have 10 different APIs to describe them. I want a consistent, uniform API. And then finally, the third thing that I care about is I want resilience. I want the ability to, when I make a network call, do the right thing if there are failures. I want to be able to make it easy to add robustness to my code. So reactive programming gives me all three of these things, and it does this all right now. And the benefit is that we can take advantage of this, and this will continue to help us in the future, obviously, because as we scale out, this will become even more relevant. So we're going to talk about reactive programming. Now, reactive programming is it's an idea, right? It's not a particular technology. We're going to talk about reactive programming and the reactive streams APIs. And we're going to talk about a project called Project Reactor, which builds on the reactive streams API. And we're going to talk about Spring, of course. But reactive programming itself is a very simple idea, okay? And it's an idea that gives us an answer to those three concerns: resource efficiency, reliability, and uniformity, right? Ease of composition. So let's take a look at all that. Now that we kind of understand the goal, let's go ahead and see how we can get all that. And of course, to do this, we're going to go to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a new service called the customers service. And we're going to use Maven is fine. You can use Maven or Gradle. Either one is great. Language, Java, Kotlin, Groovy, all of them are great choices. We're going to use the latest and greatest version of Spring Boot. I'm happy with that. We have the choice of packaging. Obviously, leave the default, make jar, not war, obviously. But then we have the choice of what version of Java we'd like to use. And friends, we have three choices down here. We have Java's 15, 11, and 8. Three choices, but really only two choices. You see, one of these choices is a choice that you could make, but that you should not make. This choice, Java 8, is a non-choice. It's a choice that you could, but you should never, ever select. Java 15 is the current supported version of Java. Java 11 is the current long-term supported version of Java. These are both acceptable choices. Java 8 is, however, technically inferior in every way. It has less features, less syntax, less security, less performance, less robustness, less cloud awareness. It's just a terrible choice in 2020. No, almost 2021, my friends. We're a couple of weeks away from a brand new year at most, less than 2 weeks, and we'll be in 2021. And so you should avoid Java 8 at all costs. Very bad choice. It's also morally the inferior choice. It's morally inferior in every way. Imagine, my friends, the look of sadness and despair on your children's faces when they find out that you're using Java 8 in production. Don't do this, my friends. Be the change that you want to see. Do the right thing. Use Java 11 or later, okay? So I'm going to use Java 11. That's just fine. I'm happy with that. And then we're going to add some dependencies. We're going to bring in the config client for centralized configuration. We're going to use the reactive web support. We're going to use R2DBC. R2DBC is a relational reactive database connectivity abstraction. We're going to use an H2 database, which is an in-memory embedded SQL database that we'll use to store all of our database code records. We're going to bring in the Spring Boot actuator. We're going to bring in Lombok. Lombok's a compile time annotation processor. And I think I'm happy with my selections here. Lombok, actuator, H2, reactive web, config client. Oh, you know what else I want to bring in? I want to bring in the RabbitMQ support here. AMQP, et voila. Okay, so there's my different dependencies. There's my different libraries, my different jars. And I'm going to go ahead and hit generate. Okay, so I'm happy with this. Let's go ahead and open it up. And we'll open this up here. Okay. Downloads. UAO customers at this. So I'm just going to open this up in my IDE. It doesn't matter what IDE you use. Anything is just fine, my friends, so long as that IDE supports Java 11 or later, and so long as it supports Maven or Gradle. So Visual Studio Code is a good choice. A lot of people seem to be really happy with that. I like it quite a bit. Later, thank you. Visual Studio Code, of course, uses this concept of a language server. A language server is a process. It's a process that's written in whatever language you want that speaks a particular protocol. And the IDE, the IDE like Visual Studio Code or the Spring Tool Suite or Atom or Emacs, they can all speak this protocol to these language services. Okay, and those language servers understand how to analyze and work with particular kinds of code bases. So you might have a language server written in Go for Go code, one in Java for Java code, one in C# for .NET, and so on. But it doesn't matter because they all speak the same protocol. And so you can reuse these plugins across different IDEs. And so we worked on the Spring support for Eclipse with the Spring Tool Suite, and then we contributed that to Visual Studio Code as well. So there's a lot of really interesting opportunities here. Anything works just fine. You can also use IntelliJ, the Community Edition or the Ultimate Edition. Either one's fine. So here's my application.
Hey, Josh.
Yes.
Can you please increase the font size in your editor?
Don't worry. I would do this. Okay. So we have now a public static void main Maven application, and we're going to go to our build and we're going to comment out some of the dependencies that we don't need for the moment. Okay, so let's get rid of the Spring Boot starter AMQP. Put that here, and we'll get rid of this. Get rid of that. So that leaves us with Actuator, Webflux, R2DBC, and our R2DBC implementation for H2. So R2DBC is a set of interfaces that we on the Spring team developed, and then we donated to the Reactive Foundation. So it's now an open thing that people contribute to, of course, and we have a number of different vendors that have already taken charge or control of the implementations for their particular database. So, for example, the Postgres R2DBC driver is being developed by the Postgres team, and there's R2DBC databases for database drivers for Microsoft SQL Server, Oracle, H2, MySQL, MariaDB, SAP HANA, Google Cloud Spanner, Azure Cosmos DB, everything, right? Just all the big ones are there, I think, and so check it out. But I'm going to use in-memory H2. Okay, so there's my build. There's my application. Let's go ahead and build an application that talks to the database. So I'm going to build an application that manages data of type customer, private integer ID, private string name. I'm going to have ID as the primary key there. We use data at all constructor, no constructor. So there's my basic object, right? And there's my private ID. And then I want to save instances of this type into the database. So I'll create a repository. And this repository handles the boring read, write, update, and delete lifecycle management methods, right? So I'll use this custom repository. This will be provided by Spring. I don't have to implement anything, but it has methods that are very useful. Methods like save, find, count, delete, etc. What is most interesting to me, of course, are the parameter types and the return values. The first parameter type that you'll see a lot in reactive programming is org reactive streams publisher. Now, org reactive streams publisher is a type that produces data asynchronously to a subscriber. It broadcasts or emits or publishes this data asynchronously to a subscriber. When the subscriber first subscribes to the org Reactive Streams publisher, it is given a subscription. And this is very important. We'll come back to the subscription in a second. When the publisher sends new records to the subscriber, they are delivered through the onNext method. When there are errors to deliver to the subscriber, they are delivered through the onError method. And finally, when the subscriber has processed all the data that it is going to be given, that is signaled here through the onComplete method. Now, the onSubscribe method is super important because it's in that method that the subscriber is given a subscription. This subscription is what the subscriber uses to ask for more data. You say, the subscriber can say, I want to request 5 more records, please, or 100 more records, or whatever. So the subscriber can request as much as it wants. If it says -1, then the publisher will give it everything it has as fast as it can. But it's important that if you say I request only 10 records, then the publisher will never give you more than 10 records. You might get 10 records, maybe 1 record a week, or maybe 1 record every nanosecond, right? You don't know. There's nothing in the prescription there. Either way, the guarantee is that you won't be given more than you can handle, more than you have asked for, right? And if you're just tired of the data and you don't want to deal with it anymore, you can also cancel, right? You can say .cancel. So this has the effect of giving the subscriber the thing that's actually processing the data, giving that subscriber a chance to control the speed at which it consumes data. This is so very important because it means that the subscriber cannot be overwhelmed, right, by anybody besides itself. The subscriber decides how quickly it should worry about the data. That's very important, very, very important. This is important at the big systems level, right? This is why people use message queues, for example, so that when one side sends too much data to the other side, the extra data gets stored in the message broker, in the message queue. It helps create more robust, more resilient systems. The subscriber can also, the other place where this is very important is also at the protocol level, right? The network protocols that you use all have a state machine that's designed to describe what happens when one side goes faster than the other, right? It's called flow control, and this is a very simple concept. The message broker helps you with flow control. The protocols, you know, they have the state machine to deal with protocols. Flow control is very, very important. And sometimes in the world of reactive programming, we talk about flow control or back pressure, right? So when you hear the term back pressure, that's just another way to say flow control. And all that we have done is we have taken this idea of flow control and put it in this interface. That's all. That's the big important piece here, is this reactive streams type there, okay? So reactive APIs build on these reactive streams types that I just showed you from publisher and subscriber and subscription, but they're very basic. They're very basic. They're so basic, actually, that those types are also in the Java JDK. So Java util concurrent flow dot processor dot subscription dot subscriber dot publisher. So these are the exact same types in the JDK, and you can convert from one to the other using the Java adapters class, right? So flow adapters, rather, using this, right? And this is in the org reactive streams type package, right? So flow adapters, this will convert between reactive streams APIs and Java 9 flow API. The Java 9 flow API came after the org reactive streams one, right? So this is compatible with Java 8, whereas this assumes Java 9. But you, of course, are using Java 11, right? So, right? Right, let's just say yes. So the point is, now we have these reactive types, but they are very basic. They're very basic, and they don't give us a lot of support for data flow composition, for analysis, for processing, for all these kinds of operations that people want to do on streams of data. So we have another project that you should know about called Reactor. Project Reactor is a project that was developed by the Spring team as well, and it is designed to support reactive stream APIs, the same ones that we just looked at, but it provides 2 specialized types. The first is mono. A mono is a thing that produces at most 1 value, and there's a lot of operators. Look at all those operators. My goodness, so many operators. These operators support things like map and flat map and filter, you know, useful things that you might be familiar with if you've done any kind of functional programming, right? Like, for example, using the Java 8 Streams API. We also have Flex. Flex is another specialization, also from Reactor Core. And a Flex is a thing that publishes more, 0, 1, 2, 5, 10, 1,000, etc. It could be unlimited, right? So Flex is a publisher. Mono is a publisher. Mono only produces at most one value. So it's like a completable future, but with back pressure. A Flex supports as many values as you want. So it's kind of like a Java 8 Streams API, but with back pressure, right? So the nice thing about this is that this is all just in the interface here. And you can see the return values are monos and flexes, but the accepted input types are the basic interface of publisher. So you can accept publishers from different projects. And there's lots of different Reactive Streams implementations. You can use Akka Streams, you can use RxJava, you can use Vertex. I mean, you can use Spring with these other technologies because they all understand Reactive Streams. Okay, so now I've got my repository, and what I want to do is I want to save some data into the database. So I'm going to create a bean that's going to listen for an event. And when this event occurs, we'll then write some data to the database, and we're going to do so using the customer repository that we created here. And we also want to initialize our database. So I'm going to create a database client, DBC, and we'll use that to initialize the database, okay? So here's what we're going to do. We're going to say that, first of all, we want to initialize the database schema because remember, it's embedded. So we'll say create table, customer, ID, serial, primary key, not null, okay? Actually, that's fine. And then name var car 255, not null. Okay. So there's that. And then I'm going to fetch and I'm going to do rows updated. So there's my mono of integer. That's the first thing I need to do, right? DDL. And then the next thing I want to do is I want to save the data into the database. So I'm going to create a reactive stream, and we're going to create some data for that database, right? So here's our stream. We're going to create some names. Who should we put in the stream? How about some people on the Spring team? Okay, so we've got some good people on the Spring team. We've got Olga, of course. We've got Violetta, of course. We've got Marcin. We've got Spencer. We've got Stefan. Okay, we've got Yushin. We've got Dr. Sire and me. I'm on their Spring team too, right? So there's some names, okay? Now the problem is that these are just names. I want to turn these names into customers. So I'm going to visit each one. I'll say take each name, turn it into a new customer, like so, right? Null for the ID, and then for the name, I'll do that. And then for each one of those, I'm going to save it to the database. So I'm going to take the customer, and I'm going to call the repository.save. And you notice that I do this because I want to call the save method, and the save method returns a mono. It returns a single value of customer. And so if I don't use flat map, if I use map, then I have to do this. That's very ugly. I have a reactive type inside of a reactive type. So instead of doing that, I want to flatten the innermost reactive type. And so you use flat map, right? You flatten the curve and you flat map, okay? So this will, let's see, this is step 1 right here, step 2, and then step 3, I want to get the data. I want to say customer repository dot find all. There we go. There's all the data. Okay. So now I want to take all that data and I want to create. I want to run it. Now nothing will run right now. If I run this code right now, nothing will happen. You need to activate it, right? What we have done is we have described a pipeline. Water will flow through the pipeline, but we have not turned on the faucet. In order to do that, you must say ddl.subscribe, right? Like this. But of course, the problem is that when you subscribe, there's no guarantee that that will execute on the same thread as the caller, right? So if I say names.subscribe and then I say all.subscribe, well, we don't know when this will finish. It might finish after this is finished, right? Because subscribe will run on a different thread. The work will be done on a different thread. So I need to force DDL to happen before names, and that has to happen before all. So I'll say DDL.then many names. And I'll say then many, all, and then finally, finally, I'm going to subscribe to the whole thing to print out each new record that's been written there, right? So I'm just running these things in a sequence like this. So let's see what that looks like. Let's run this and see what we get. ID serial. Let's see here. What did I do? First of all, did I import this correctly? And then second of all, create table customer ID serial primary key name. Oh, huh. Okay. Recompiling. Okay, there we go. There's our 8 records in the database. It's working. Okay, good. So now the next thing I want is I want to create an HTTP endpoint, right? So I'll say that, well, actually, you know what? We can do it this way. We can create a Spring MVC style REST controller, class customer REST controller, right? Private final customer repository. And I'll inject this into the constructor. And we're just going to create an endpoint here called customers. Okay, publisher of customer get. Find all, and voila. Okay, there's my customer repository. And I'm going to go ahead and restart this. So save, restart, recompile, good, localhost 8080 / customers. And there's our data. So it's working. So good. We have now an application with HTTP data. We have, SQL data. We have our records. It's fine. I think we're ready to go to production. What do we have to care about when we go to production? Well, of course, there's a lot of concerns when you go to production. First of all, I want to make sure that my application is observable. And so I'm going to use the Spring Boot actuator to include all these endpoints that give information about the state of my service. I'm also going to deploy to a Kubernetes cluster probably, right? So I want to make sure that my application is ready to support integration with the Kubernetes platform. So we have these health liveness and health readiness probes that we can enable. So I'm turning those on as well. So let's go ahead and run this and see what we get for that. Okay, now the actuator are a set of managed HTTP endpoints that give you information like the metrics, the health, the uptime, thread dump, lots of information about your application that you can use to understand how the application is doing. So you can see here that I've got a health endpoint and it's got 2 probes. Liveness tells Kubernetes whether the service is still alive, right? Readiness tells Kubernetes whether, when the application starts up, whether it is ready to be put into the load balancer and start receiving traffic. And you can change this, of course, right? You can actually change the endpoints. So let's say I create another endpoint here, REST controller class down REST controller, right? And what I'm going to do is I'm going to inject the application context, okay? And I'm going to create an endpoint here, post mapping down, mono avoid down. And I want to publish an event. I want to publish an event in the application context to other components in the context that are listening for it. So here, I'm going to publish an event to tell the Spring application context that something is wrong, and therefore it should change this liveness probe to be down, right? So liveness, okay? And so you can do this by saying availability change event dot publish. And we put the liveness state broken, okay? So I'm just going to publish this event like so. Okay, let's run this again. Actually, just to make my life go a little faster, it's not very restful. Okay, it's not restful, but that'll be quicker so I don't have to use curl. Okay, so go to this endpoint. Everything's fine. we go here, now it goes down, right? I use that event to force this to go down. So what happens when it goes down? Well, you're going to have the heartbeat probe from Kubernetes. It's going to check by default every 1 second on these configured, heartbeat, the liveness and readiness probes. And when it sees that the service is down, it's going to take the service and it's going to kill the container and create a new one, right? But you can tell it that you want to have the container container destroyed after it's been taken out of the load balancer. So you have some time. That time is very useful because just because it's no longer in the load balancer doesn't mean that the pod itself should be destroyed. So you can take it out of the load balancer and then let the existing transactions, the online requests, you can let those finish, and then the platform will put a different instance into the load balancer in the meantime, right? So this is very useful. You have, by default, I think it's like 30 seconds, right? So you can actually enable this graceful shutdown feature in Spring Boot as well. You can tell Spring Boot that I want my shutdown to be not immediate, but graceful. That way, it'll stop accepting new traffic, but it can finish any existing requests and send back, finish anything that's in flight. And we can specify how long it should be, right? We can say that we want it to be 30 seconds. Okay, so this graceful shutdown thing is very useful for that. Now, what else will happen then, right? The service will go down. It'll no longer be in the cluster, and then another instance will be spun up. So already we've got a lot of things that are included out of the box to make it easy to do the right thing with the platform. But now, how do we get to the platform, right? This is the next thing that most of us are going to think about. And so one option is to use something called a build pack, right? We need to take our application and turn it into a build, into a container, right? And so we can use build packs. Build packs solve one of the hardest, biggest, painful problems in the cloud native world, right? Which is Docker files. The first most painful thing in the cloud native world is, of course, YAML. I hate YAML. This is one of my favorite cartoons about YAML from my friend Arun Gupta. I think we can do better. YAML is the reason that people leave IT. Not a big fan. So we can do better. Now, Docker files, that's another big pain point. And so Paketo build packs help you solve that, right? They help you get rid of them because what they do is they take the application artifact and they turn it into a container. So you give it a Java jar, a Spring Boot jar, for example, and it'll download a JDK and create a file system and create the right memory configuration and then create a container for that. If you use Go or PHP or .NET or Ruby on Rails or Python or whatever, there's dozens or hundreds of build packs out there. It'll do the same thing for those languages as well. And so you can actually use a command line tool called pack. You can say pack space build space period, and then it'll take the code I can go down here, Maven Spring Boot build -image, right? And what that'll do is it'll run. It's going to take my application and turn it into a container, which I can then Docker tag and then Docker push to my container registry, right? And you can use VMware Harbor, you can use Google Container Registry, you can use Docker Hub, all these different things, right? It doesn't matter what you use. And the nice thing is that because we have a specific version of the Maven build plugin, we have a very specific version configured of the build pack. If you use the same code in the same build pack, you get the same exact container over and over. And of course, you can change these things. You can evolve them. You can upgrade them. But it's nice to know that you get consistent results, reproducible results, right? So you can see it's downloading the Liberica JDK there and setting up everything. And it realizes that this is a web application. And so it's just adding all these kinds of things to the different layers and creating an environment with the different things that we need. And there it is, right? So there's the entire container. Took a minute to do that. Docker run, and there's my application. And of course, it's running inside of an in-memory database. It's got a database that we start up when the application starts up. So there's our application data. right? So that's good. So the container's working. The thing is, I want this to go faster, right? I want this to be, I want this to take as little memory as possible at runtime, and I want it to start up quicker because time is money, right? So one option that we can use is to use GraalVM. GraalVM has support for native images. The idea behind native images is that it's a closed world approach to compiling applications. Basically, we take Java and we shake away all the fun stuff, so all the dynamic behavior, runtime reflection, class loading, proxies, resource loading from jars, all that stuff, throw it away. But if you can do that, if you can identify all that, GraalVM can help you fake it. You can pretend that you've got these things so that your code will still work. That's one option. And then, of course, if you do this, then you get a native image. You get an actual application that is a machine architecture specific binary that runs only on, let's say, Linux or Mac or whatever. And this is okay because in the cloud, everything is Linux anyway, right? And so I like native image support. And you can easily do this with a project called Spring GraalVM. But we need to set up a few things. First of all, we change our code here. We have to do that, right? And then we have to configure a few things in our build. And I've done this already. Here, you can look at the example for reference, right? And this example, I go here, I'm using Spring Boot 2.41. I'm going to use the Spring GraalVM native dependency there. This is not yet GA, but we would love to have your feedback, of course. And we paste this in here. Okay, so Spring GraalVM native. And then we go down and we go to our build. And we're going to configure the Maven build plugin to change the default container that gets created. Instead of creating a container with the JVM, we're going to create a native image container. Okay, so we go here, and you can see we're going to use a Paketo build pack called Tiny, and that's going to use build pack boot native image, right? So once we have these things configured, I think that's it. I think that's all we have to do. Then we can just run the build. Now, this will take a little while, okay? This actually takes a long time. It's not fast. So this is one of those things where you'll probably end up doing it in your CI environment or something like this. So we're going to go ahead and let that run. And then in the meantime, I want to build another service, okay? This might take like 5-10 minutes. I don't know. It takes forever. So we're going to go ahead and create another service. We'll go back to start.spring.io. And here, we're going to create a new service, not called customers, but called orders. So in this case, this is a different bounded context because even if you have a customer account or a customer record and you delete the data, you will still keep the order service and all the order data because you need to care about it for revenue recognition and that kind of stuff. So we're going to create a new service, and this one will not use HTTP. Instead, we're going to use RSocket. RSocket is a reactive protocol that is natively reactive on the wire. It was developed by the engineers at Facebook and Netflix, and it is designed to get around some of the many limitations of HTTP2 and gRPC and so on. It is flexible in that it supports true bidirectional communication. It's not just request response. It also supports fire and forget and streaming and so on in both directions, of course. It is rich in that it supports things like observability. It has a message frame designed to support metadata about the service. It has headers or metadata header, the kind of thing you need to send, let's say, a token, right? And so because of that, it's very easy to integrate into the Spring ecosystem. The Java client for this protocol was built on top of Reactor. This makes it very simple for anybody using Spring, which is already using Reactor, to take advantage of this. And so we are very excited to work with the engineers at Facebook as they're working on this. And we actually ended up working so much with them that this all got donated to the Reactive Foundation. So the Spring team and Facebook and Alibaba and a number of other large organizations that care about this kind of stuff have all been working together to make RSocket a really nice experience for people who are trying to build high performance, reliable, resilient services. And so we even extended Spring Framework itself to provide a component model for RSocket. So we're going to use that. We're going to use Lombok. We're going to use let's see, we're going to use AMQP, right? We're going to use Spring Cloud Stream, okay? And I think we also want the config. I want the config client. So config client. Okay, so that's everything, I think. Let me show this in folder, orders, Explorer, download. Okay, so let's open this up in my IDE. Orders application. And so what we're going to do here is we're going to create a simple service, simple RSocket controller that will serve up order data. But we need to create the RSocket server process. So we're going to create this one and have it run on 8181. And then we're going to create the controller. We're going to say, okay, add controller class RSocket order controller, right? Instead of the customer controller. Or maybe we can do, maybe it's the other way around. Maybe we do it like this. Right, order, there you go. So when the application starts up, we're going to create some in-memory data. Okay, you could easily talk to any database; it would be no problem. But let's just have an in-memory database here, and we're going to create a little map. So private final map of integer to a collection of order objects. Okay, new concurrent hash map, and we're going to create a class here, class order, private integer. Whoop. ID, private string. Well, you know what? We want the ID as, which is going to be the order ID as well as the customer ID. It's a dotted line linked to that, right? There we go. So there's my basic dependencies, and here's my map, my in-memory database, and I want to now fill it up. So what we're going to do is we're going to remember I have 8 records. So I'll say for var customer ID equals 1. Customer ID is less than or equal to 8, customer ID plus plus. And then here, var orders list equals new array list of order. And for var order ID equals 1, order ID is less than or equal to math.random times, let's say 100, okay, or 50. There we go. So we're going to just create a certain amount of data. Okay, I'm going to say orders list, add new order. Okay, and it'll be order ID, customer ID. There we go. So that's the basic order thing, and then we're just going to put that in the database. We'll say this.db.put customer ID orders. So now when somebody comes asking for the data in this RSocket controller, we can just look it up in that in-memory map of data. Okay, so here's my message mapping endpoint. It's going to have a destination string, so I'll say customer ID. We'll say publisher, return a publisher of order. So flux.from iterable this.db.get or default this, and the ID, of course, will be this parameter here that I'm going to inject into the controller handler method. So customer ID collections.empty list. Yep. Empty list. Okay. So there's my database call. My actual RSocket code is very easy, right? I spent more time just writing this silly data code here. So there's my entire application. Let's go ahead and start this up, and let's go check on our okay, there it is. This finished. Okay, look. So now this took 5 minutes and 10 seconds. You can see it took a while. Run that, and there's my application. It starts up in 0.15 seconds, right? I've got my application. There's all the data in the database. It's got, and remember, this is not just my Spring Boot application. This is an in-memory database. I'm starting up a whole database in the Java process, and it's really fast. And the best part about this is not the startup, because who cares? That's really not, most architectures don't care about that, right? What we care about is the memory footprint at runtime, right? If I am running this in production, this takes tens of megabytes, maybe 50 megabytes or 20 megabytes or 30. It doesn't take hundreds or thousands of megabytes. It doesn't take that at all. It's very, very efficient. So now I have this very lightweight thing. I can deploy many instances of this for cheap. It doesn't cost as much, So it's a wonderful technology to be able to use that and to be able to have it in production. So now I have my customer service and I have my order service. I want these things to, I've got configuration. You saw I have configuration here. I have configuration here. I want this configuration to be stored somewhere centrally. So, one of these things that's really nice in the Spring Cloud ecosystem is we have this thing called the Spring Cloud Configuration Server. And the Spring Cloud Configuration Server is just a Java API that sits in front of a repository of configuration, like a Git repository, right? And the repository, the Spring Cloud Config Server, acts as a proxy to the configuration from your Git repository. It could be on GitHub, it could be local, it could be whatever. And so you can point this config server to the Git repository, and it'll act as a facade, and it'll allow clients to request particular versions of profile data for a particular application. So let's say enable config server. And then here we're going to say Spring Cloud config server get URI equals that, right? Maybe you use HTTPS. Okay. I want the port to be 8888. And that's it. So we can now run this. That's not it. I forgot one more thing. The other thing is on GitHub right now, if you're using GitHub, in the last few months, I think it feels very recent. And recently, GitHub changed the policy so that when you create a brand new repository, the branch is no longer called master. It's called main, which makes sense, right? It's we're trying to get rid of words that are insensitive, which good idea. But because of that, you have to remember, which is not a big deal, right? Not a big deal. You have to remember that in Spring Cloud for the moment, it'll change in the future, of course, but for now, we have to tell it to use main as the default one, okay? So that tripped me up. I was like, oh, what's going on? This used to work a million times. Oh, okay. The branch is different. Okay, so no big deal. Let's go ahead and restart it. Okay, so now there's our application, localhost 8888. So now imagine I am the customer's microservice. I go to the URL here, customers. I get the configuration properties called customers.properties. And here I can see the keys and values. I can see that my server port is going to be 8082. So let's now go to our customer service here. And, we don't need all this. We're going to say that the application name is called customers. We're going to say that we want to import the configuration, not from a config tree. A config tree, by the way, is like a volume mounted config map from Kubernetes, right? That's what this is, but that's not what we're going to be using. We're not going to be using files or class path. Instead, we're going to use a config server URL, right? And actually, I could do this. I could say, like this, if I wanted to. That would be okay. But I don't even need to do that because by default, it's going to look for this property called, well, I need the configuration, don't I? I need the dependency there. So Spring Cloud Starter config, Maven reload. Okay, Spring Cloud. So it's going to look for this property, localhost 8888, and that's actually the default. So you don't even really need that, but it's just nice to know that it's there. So these are the two things I need. And then once I do this, this will start not on port 8080, but it'll start on port 8082. So let's go ahead and restart this. And then over here on the order side, we need to do the same thing. We're going to say Spring application name equals orders, Spring config import, config server colon. Okay. Now, this will start up. Let's see what the configuration is. Oh, did I bring in the build dependency? Config, it's there. Good. Okay, so that'll start up. Now the config server is going to create the RSocket endpoint on port 8181. Okay, so let's try that out. There's a nice command line utility that's kind of like curl for RSocket. So it's called RSC TTP localhost streaming the data. The route is called orders, and then we specify a customer ID like 2. And so there's the data for customer ID 2, for 4, for 6, etc. Right? So we don't have a 10, but there's that, blah, blah, blah. Okay. So there's our services. They're both working. There's the order service, the customer service. We've got the config service. Now I want to build a gateway. Okay. So I'm going to go back to start.spring.io, and I'm going to build an application that will be the edge service, the gateway for the code. So I'm going to use the reactive web support. I'm going to use RSocket. I'll use Lombok. I'll use the config client. I'll use the RabbitMQ stream support. And I think that's it. I think I'm happy with that selection. So then we'll just open this up in the IDE. Now, the gateway is a great place to put generic cross-cutting kinds of concerns. Things like routing and refreshing and configuration and security for authentication and authorization and load balancing and retries and compression and all these kinds of things. You can put them here, and this will act as a proxy. So the outside requests will come to the proxy, then they get transformed, and then they get sent to the downstream microservices in your environment, right? And so we're going to create an application that will connect to the config server. So Spring application name equals gateway, spring.config import config import config server. Okay, and so we're going to create a Spring Cloud Gateway application first. Spring Cloud Gateway is a project that allows you to describe how to route requests through the application. So you say rlb.build route, and then here you have routes, and the routes must match the requests that come into the host and port for the gateway microservice. And then they get matched, and then they get forwarded or they get proxied to another microservice. So here I will say that when a request comes in to the path called proxy, then I want to send it to this service, localhost 8082 customers. I want to send it to the customer's endpoint. The problem, of course, is that the path here is already proxy, and if I add a path here, then what will I get? Will it be 8082 customers / proxy? I mean, we have to get rid of proxy, right? So we can use a filter here, filter spec. We can say gateway filter spec set path customers, right? So the incoming request will be transformed. That's the power of these filters, is the ability to act on these incoming requests. And this, of course, all builds on the reactive APIs. And you can do really amazing things. You can say, oh, well, I want to add a header like so, right? So access control, allow origin. Or I can do a retry, right? 10 times. Or I can do a redirect, right? I can do all sorts of interesting things here at this filter level. There's rate limiting, there's security, I mean, anything you want. Or you can just write your own filter, right? Any kind of generic filter, new gateway filter. So this is a great place to put your generic cross-cutting kinds of concerns. So let's try this out. Let's see if we've got this to work already, right? So it's going to go to this service / customers. And we're going to allow CORS headers. That way, even if this service here doesn't have CORS headers, because it's going through the proxy, this will. So this proxy, the Spring Cloud Gateway, it's great for, if you want to build an ingress controller in Kubernetes, if you want to do a route service in Cloud Foundry, this is a natural thing to do that with. Okay, so localhost 9999 / proxy, right? There you go, proxy. So there's my data on port 9999. It's calling the downstream customer service on port 8082. Okay, so that's very generic, right? I don't really know about the data that's going through here. But what if I wanted to create a view on the data, right? I wanted to create a materialized view of something that showed me the orders and the customers in one page, one thing, okay? So I'll go here, CRM client, and I'll create, I'm gonna copy and paste the DTO types, the data types for the customers and the orders. So go to the orders, copy and paste this to the gateway, paste, window, customers, Okay. There we go. Good. Alrighty. So there's that. Maven. Oh, there we go. So there's my basic arrangement. Now I'm going to create a client to talk to them both. Okay. And this means I need to make a network call using HTTP and another one using RSocket. Okay. These are both, I'm going to use non-blocking reactive clients. Okay. So for HTTP, I use the Spring Framework web client, which is a great non-blocking HTTP client. And so if you want to do any kind of network calls, HTTP network calls, use the web client. It is awesome, right? It's really, really built for this kind of stuff. I prefer it over the REST template by a lot, these days. Really, really powerful. You can use the web client even, of course you know this, but you can call non-reactive services using the web client, right? So very, very convenient. So let's say publisher of customer, okay, return. So how are we going to make this? We've got to make this network call. What's the easy way to do that? Well, we say return this.http.get HTTP localhost 8082, okay, customers. The data will come back as JSON. I'm going to convert it into a reactive stream of customers, like so. Okay. There you go. Okay, there's my customers. I want to get the reactive stream of RSocket data as well. So here I'll use the non-blocking RSocket client called the RSocket requester. And except the difference is that we don't actually call this a client because it's not, right? In the RSocket world, you have two sides that connect, but one side, once connected to the other, stays connected, and they can do whatever they want. Either side can send a message at whatever time it wants. So there's no real client server anymore. We say requester, responder. I can be the requester and you the responder, but later you can become the requester and I am the responder. It's true bi-directional communication. So we don't, it's a different name, but logically we use it to act as a client, okay? So RSocket requester.builder. And one of the nice things is that with RSocket, the connection is established at the very beginning of the life cycle of the application, and it stays connected. You don't have to reconnect each time, so that makes network calls a lot more performant, okay? So you specify the host and port when you build the client, right? You just do it once. You can also make it easy to specify how to reconnect, and all that stuff is very easy to do, but for now, let's just get moving on. So we here, publish order, get orders for integer customer ID. Return this.rsocket.route orders customer ID. Right? So I'm going to say, give me the stream containing orders data. Right? So there's the network call across the wire there. Now I've made two calls here. I'm making two calls across the network here using the get customers endpoint and the get orders endpoint. Now, is this going to work all the time? I think not. Of course not, right? There's going to be issues. Things will fail. Of course they'll fail. So it's the network, right? You've got to be aware of the risk that you have there. So what I want to do is make my code a little bit more robust. One thing I can do is to configure a retry. Maybe I retry 10 times. Maybe I retry and then do a back off, right? Of seconds, 10, that kind of thing. Okay. I can also do on error resume. I can say when something goes wrong and there's an exception, then let's say instead of sending a stack trace, I can do an empty stream, right? I can just return an empty collection, basically. Okay, what about timeout, right? Well, timeouts are useful, right? So we can say timeout duration of seconds 10, for example. Okay, so lots of different things we could do here. But let's talk about this timeout. Why do we use timeouts? Well, timeouts, we use them because they give us a way to say when this has spent too much time and we are at risk of violating our SLA, then stop the work and then give us another chance to try again. So for example, maybe a client makes a request to the gateway, and the gateway has to make a call to another service, and that other service has to make a call to yet another service. Well, let's say at the gateway, we have a really, really generous, crazy nice, very generous 20 seconds, which is an eternity, right? That's forever in computer. But for simple math, we have 20 seconds at the gateway, right? For SLA. Well, the gateway calls the customer service. Well, that's 10 seconds, right? Is the SLA there? Because that way, if it fails, and we can time box it to 10 seconds, then if it fails, we can still try again and make the SLA for the gateway. Now, the customer service, in turn, maybe it calls another service. And so that takes 5 seconds. It has to be less than 5 seconds, right? And if that if that calls another one, then that calls another service, right? It has to take 2.5 seconds. You see the problem here? It decays very quickly because we're further away from the origin of the request. And so the further we are away, the harder it is to scale, to manage that response. So what we want is some way, and by the way, what does this give us? Well, if it takes 10 seconds, that means we can only try it 2 times, right? 2 times for this, 2 times for that. So that's not many bites of the apple, right? It's not many opportunities to succeed. What we want is more chances and less waste, right? So one pattern that is very common is called hedging. And with hedging, Google and Uber and Netflix, they've all used hedging, right? Hedging is very convenient. And the idea is that you want to diversify the risk. In English, when we say to hedge your bets, we're saying don't put all of your money in one stock, or you might know the expression, don't put all of your eggs in one basket, right? Basically, don't risk everything on one possibility. Instead, split it across a number of possibilities so that if something fails or something goes wrong, you still have backups, right? And the same idea is here. Instead of calling one service and then hoping that you get a response and then timing out, why don't you call the same service on, let's say, 2 hosts or 3 hosts, 3 different hosts, right? Same exact microservice, same API, but it's on different hosts and ports, okay? And that way, even if one of them fails, or, worst case, 2 fail, you've still got one that'll give you a response. So maybe the service, this happens a lot, right? Maybe the service is garbage collecting. Maybe the service is, out to lunch. Who knows? Maybe it's the power just went off. Things will fail. So this pattern is very simple, but think about what you have to do to make it work. You want to make the same network request to the same service on 3 or 4 or whatever different hosts and ports. Well, that's not easy, right? Because now you've got network calls. You've got 3 concurrent calls that have to be done at the same network, at the same time. And then whichever one is fastest, you keep. You keep the fastest one and you throw away the other 2, right? So you've got kind of a race condition. This is not easy code to write with regular Java threads and executors and runnables and all that. Sorry. This is difficult threaded code to write. And yet with reactive APIs, it's easy, very easy. You can just say, let's say I have, I have a network call for host 1, host 2, and host 3, okay? And obviously, you already know what this is, right? You know how to do this now, right? So imagine it's just this. This is host 1, and then I change host 2, host 3, right? So imagine I've got now 3 pipelines. I haven't launched them yet. And what I want to do is I want to say, okay, I want the first one to respond. I keep that one and throw away the other slow 2, right? So this will give me the fastest of the 3, and it'll apply back pressure to cancel the other 2. See how easy that was? Try imagining what you would have to do. Count down latches, maybe cyclic barriers, runnables, phasers, executors, and threads, and runnable. I mean, just not fun code to write in multi-threaded Java. Remember, there's only one person who truly understands how to write multi-threaded Java code. And it's not you, my friends. It's definitely not me. I don't know who it is. But the point is, we shouldn't risk finding out. Let's let the framework do the work for us. And this is a good reason why people use Reactor, why Facebook used Reactor when they built RSocket. It's why Microsoft, for all of their Microsoft Azure APIs and clients, recommends using Reactor for their Java APIs, right? So this is a very good idea, and you can see it. It makes a lot of really complex stuff very easy. This pattern, of course, I should say, this only works for the HTTP endpoints where you can call the same thing multiple times and not get a bad result. So it's idempotent, right? You should not use this practice on the charge the customer credit card endpoint. Not a good idea, right? But very, very useful pattern. It's trivial to do this in a reactive fashion. So we've looked now at how you can make your APIs more robust. We looked at different patterns that you can use to support that. I've got my RSocket code and my HTTP code, and you can see they're both just publishers. It's a publisher of customer and a publisher of orders. And so now let's say I want to compose both of these. Okay, so class customer orders, private customer, okay, private list of orders. Okay, so I've just got like an aggregate type, a view on data. Okay, so I'm gonna make network calls to both services at the same time and get as much data back as I can, and I'm gonna stream it back into a materialized view of the data. So customer orders, get customer orders, return this.get customers, and for each customer, I want to call the microservice for the orders. I want to get all the orders for each customer, but I need to keep both of them in memory at the same time. So I want to accumulate, I want to keep the customers and all the orders for that customer in memory at the same time. So what I'll do is I'm going to create a tuple, right? A tuple is a type that has named, it's got typed parameters, typed index position. So type 1, type 2, or position 1, position 2, etc. And the benefit is it's just a great way to store data when you do these functional kinds of transformations. So I'm going to say flux.zip, and I'll store the first item from these two monos. Okay. So I've got on the left, I've got the mono for the customer, and on the right, I'll say, give me the orders for customer.getID. I'm going to turn this into a list. Okay. Okay. So now I've got this, and then for each one of those tuples, I need to create a new customer orders type. So I'll say tuple dot get T1. You can see T1 is equal to customer. Tuple get T2 is equal to list of order. Right? So customers, oh, is this just map? There you go, map. Okay. So this is my reactive pipeline. I'm making a network call for each customer. I'm calling out and getting all the orders. But remember, this isn't one after the other. It's going through all the customers in concurrence at the same time, and then as it gets each customer, it's going and launching all the calls for the orders. So I might have 5 threads running at the same time, getting different orders. Even though it's an n+1, it's still acting concurrently as much as it can. So we're getting the most efficient, most resource efficient code, and we're never blocking the thread. We're never sitting on a thread waiting for something to happen when we could reuse the thread, right? This is one of the big benefits of reactive programming, is that we're making sure that the runtime has access to that thread and that others can use it. So now we've got this customer orders endpoint. Let's go ahead and create a functional reactive style. So I showed you earlier how to use the Spring MVC style HTTP endpoints, right? But you can also use this functional style, which I quite like as well, right? So here, build.get customers. Actually, we're going to call it COs. New handler function. Okay. Server response.ok.body, and we're going to use the CRM client that we built. I'm going to say crm.get customer orders, customer orders.class. Okay, there we are. Good. Good. Okay, so there's my HTTP client, my HTTP endpoint. Let's go ahead and start this up and see what we get. And you can see that this functional reactive style, by the way, is very, very lightweight, right? Like this is it. That's the one thing, and it's a builder DSL, so I can do things like this, whatever, right? It's fluid. Okay, this will probably fail because that's already running. So let's close conflict on the of the port there. Okay, so now, there we go. Olga, and there's the orders for Olga, right? And if I go down here, Marcin, there are the customers for Marcin, or the orders for Marcin, right? Go down here, Spencer, there's all the orders for Spencer. So you can see I'm able to make these network calls really quick. It's obviously very fast, and I get the data from these two different services at the same time. And it looks like a view. This is a great, great thing for clients, because a lot of times your clients, your Android and your iPhone and whatever, they don't have a lot of bandwidth. So they go to your service. Your service does the composition on the server side. And with reactive APIs, it's very quick. It's very, very scalable and so on. So it's not a very big deal. Now, I've done a read here. I'm reading the data from the downstream services. And by the way, I'm using RSocket and I'm using HTTP, but we don't care. All we know is that we have reactive stream types, right? We have reactive publishers and monos, and fluxes, right? We're not spending time trying to, merge or glue together different APIs. Over here I've got Kafka. Over there I've got application JSON. Over here I have RabbitMQ. Over there I have server sent events or WebSockets, and they're all totally different APIs. Well, with reactive APIs, they're all publishers. It's the same thing. So it's very easy to glue things together, to integrate, to compose different reactive streams in this way. And you've seen, I just did that with RSocket and HTTP, right? The orders and the customers. It doesn't matter at the end of the day what protocol they speak. At the end of the day, I'm getting a reactive type. Now, I've got a view of the data here. But what about a write, right? In a microservice environment, I'm going to want to write. I'm going to want to update data. But of course, what am I supposed to update? I've got two services here. So when I send an update to the proxy, to the gateway, what should happen? Well, there's no such thing as distributed transactions in a distributed system like this one, right? Where the XOpen protocol, the one that is the protocol is the basis for JTA. That XOpen protocol requires that all the transactional resources that participate in the transaction support the XOpen protocol. Nothing, except for maybe H2 that I've shown you today, supports XOpen, right? And this is just the way of the world. Almost nothing does support XOpen, right? So it's not a solution, right? What we want is, instead of trying to force everything to synchronize, which is a huge loss of resource efficiency, instead of trying to do that, what we want to do is tell each service what to do and have them update their own state, their own view accordingly. So we can use a message. We're going to have an update endpoint here, and then we're going to publish that message. As soon as that endpoint gets hit, we're going to broadcast a message notifying the other services of the change. So maybe we have a delete endpoint, right? So let's go here, and we're going to create a new endpoint called delete. COs, new handler function. Say server response. Okay. Body. Okay, and here I'm going to use Spring Cloud Stream. Spring Cloud Stream will make it easy for me to send a message using the Java util function types, right? And then I can broadcast that message to a Spring Cloud Stream binder. I'm using RabbitMQ, but there are binders for Kafka, for Kafka Streams, for Redis Streams, for Google Cloud PubSub, for Azure Service Bus. I mean, for anything you can imagine, there's a binder out that you can use that's really good, right? I'm just using one that's local, and it's easy to get on my local machine, but whatever you want, right? So the benefit of this, of course, is that you write your code using generic types. You're not tied to the Spring Cloud Stream binder API. So here's how that would look. I'm going to create a supplier that's going to create a reactive stream that has all the data about which customers should be deleted, right? So customer deletion supplier. Okay. Return new supplier. My job here is to return a flux. So I'll say publisher of integer deletions. I gotta sneeze again. Excuse me. Sorry about that, friends. Okay. So I'm going to say syncs mini.multicast.on backslash. Okay. So okay, that's my deletions. For that here. I'll say deletions dot as publisher. Okay, I want to get rid of the oh, it's this right here. Yeah, sorry. Integer. There we go. Make this a method reference. Okay, so there's my basic code. This is a supplier. It's going to return a reactive stream. This reactive stream contains the integers that we want to delete. We're going to broadcast those messages to everything in the cluster. It's the tell, don't ask pattern, right? So here I'll say deletions, try emit next. I'm going to get the current. I'm going to get the delete. The customer ID that we want to delete here. I will say server request path variable customer ID, and we're going to turn this into an integer, right? Integer parse int. There you go. All right, try emit that. And is it a success? Let's see. Okay. There's my basic messaging, consumer, my producer rather. Now I need to do the same thing on the other side. I need to be a consumer, and so this is this bean that we created, this customer deletion supplier. That bean has to be configured in the code, right? So here in the gateway configuration, it says I've got a Spring Cloud function definition called customer deletions supplier. Let's make sure that's the same thing. Yep. And it's going to point to this destination in the RabbitMQ broker. Okay. Now, what about the consumer? Let's say I go to the customer's endpoint. I want to consume the event. So it's looking for a consumer, customer deletions consumer bean. So let's go ahead and restart the gateway. Okay. And we'll go to this side. And here, I'll go to my build. I've got to remember to bring in the Spring Cloud Stream binder. All right. Alrighty, now in consumer publisher of integer deletions, right? And the idea is that Spring Cloud Stream will give you a callback when the application starts up, and in that callback you're given a pointer to the stream, and so you can just subscribe to it and do whatever you want with it, right? You can say, okay, for each deletion, I want to then take the customer ID and I want to call delete on the database. So customer repository. Okay. Delete by ID, customer ID. And then finally, with that done, subscribe, right? I'm going to log out, which just happened as well. So I'll say do a next customer ID. deleting customer ID. So you can do the same thing for the order service, right? And each microservice knows what to do. It knows what a customer deletion event means for the order service versus for the customer service, right? So very natural pattern. Okay, so let's go ahead and restart this one. I don't have enough time to do both, but I think you can see the point. So we'll go ahead and now run this. Here's the customers. What about the gateway? Whoops. Oh, it's the database table. It's fine. Who cares? We're fine. So now go to the gateway. Let's see if this works. Curl -x delete HTTP localhost 9999 /COs / now let's go here for a second. So number one is Olga. We're going to delete number one. Okay. There's no more number one. Well, number two now is number one, I guess, right? So there you go, my friends. We've looked at a few things today. We looked at reactive data flow with Reactor. We looked at building reactive data access with RTDBC. We didn't even look at all the other NoSQL reactive options like Cassandra, Elasticsearch, MongoDB, Redis, Cosmos DB, Neo4j, all these different things. But we don't have enough time. We looked at reactive HTTP endpoints. We looked at RSocket. We looked at the Spring Boot actuator and the integration with Kubernetes. We looked at Docker builds and native image support with GraalVM. We looked at building, using centralized configuration with Spring Cloud Config Server. We looked at, what else did we look at? We looked at Spring Cloud Gateway. We looked at how to do reactive service orchestration and composition. We looked at patterns for reliability like hedging and on-error resume and retries. We then looked at using Spring Cloud Stream for messaging. All of the while, all this time, we're just thinking about the world in terms of reactive types. You didn't see me writing all this very different code and trying to make it all glue together. It just works together. I want to thank you so much for your time, my friends. I am very happy that we got to spend some time together. I hope you enjoyed it. Let me know who enjoyed it, right? I'm here to stick around. I'm not leaving. If there's any questions, I'm happy to answer them. I hope we get to meet again soon, right? So there's that. And thank you so much, of course. Oh.
Thank you, Josh. We can wait for questions for a bit.
I see that some people caught my mistake earlier with the closing bracket. I appreciate your pair programming with me. Yeah, Werner said that nice Bulgarian chicken soup would help cure this cold, and that's true. I miss that. And skembeche, is it? What's the stomach, the spicy stomach soup that we used to drink or have after a long night? I hope you had fun. Happy holidays, Merry Christmas, Happy New Year to all of you. Code. Okay, so the code, by the way, I showed you Reactive Revolution earlier. The other talk you might want is this one. The other code is Cloud Native Java. Let me share my screen one last time. Here. This has all the code that we looked at. This is actually the more recent one. I would use this one. Use that Git repository. Shkembe, yeah, is that the soup? Is that the animal stomach and spice and milk? That was delicious. Well, all right. You have my email, josh@joshlong.com, and my Twitter, at Starbucksman. Say hi on Twitter, would you? Always happy to make new friends. It's 2:30 in the morning with here in San Francisco. 2:30. I wish I could be in Bulgaria.
A bit off topic, but would you like to join the discussion about Java ecosystem evolution, which is starting right after your talk? Everybody likes to see you.
I was kind of hoping to go to bed. How long is it? It sounds like fun.
What?
How long?
It should be 1 hour, but you can drop early, of course, because I understand it's 2 a.m. in the morning for you.
Yeah. Is it okay if I don't? I'm beat. I see this. This is I because I've been fighting this cold, so this is coffee. Trying to stay awake for this. I'm sorry. Please forgive me. But I wish I could be there. If it was earlier the night, maybe I could have been there. I'm sorry. I'm gonna
No
pass.
worries, Josh.
I'm so sorry.
Get better.
Oh, thanks. This is so much fun. I miss you all. I love the conference. I don't know if people, Werner, he knows, and some of you know, but this conference, I'm a huge fan, right? 11 years or something like that at this wonderful show.
You've been with us for most of those 11 years, especially in the beginning.
Yeah, exactly. Especially in the beginning, and it's just been very hard to get back there. And I didn't get to go last year, and then stupid pandemic this year. So I'm glad it's not COVID too. It's just a cold. I'm sneezing. That's not COVID, right? I'm fine. Don't worry about me. But it is a cold, and it's. But anyway, I miss you all. Have a great night. Let me know if I can help. If there are any questions, whatever, let me know. Okay. Thank you again.
Thank you, Josh.